everyone, this is Ms. Nocella, and by the end of this video you should be able to identify if a function is one-to-one, find the inverse of a function, and also identify a domain and range of the inverse of a function. We are given the function f of x is equal to 4x minus 5, and the first question is the function one-to-one? So what we can do is we can graph this function. So 4x minus 5 means that we're going to start at negative 5 as our y-intercept, and then our slope is positive 4 over 1. So we're going to go ahead and graph this. And so this is a rough sketch of what our graph would look like. And in order for a function to be one-to-one, we know that for every unique input, it has to have a unique output. So in other words, another way that we can check is, does it pass the horizontal line test? Which means that if we draw any horizontal line on our graph, does it cross through the graph of the function only once? And that is true. So is this function one-to-one? Yes, it is. Now we want to find the inverse of this function and write it in function notation. So to find the inverse of a function, our first step is to replace x and y in the equation. So right now we have y is equal to 4x minus 5. So we are going to replace x and y. So we have x is equal to 4y minus 5. Now all we have to do is get y by itself. So we will get y is equal to x plus 5 divided by 4, just using inverse operations. So that means the inverse of our function is equal to the quantity x plus 5 divided by 4. Next we have to graph this inverse. So I'll graph this in yellow. So we know our slope is 1/4. And our y-intercept is 5/4. So that is 1.25. So I'm going to graph this here. And we're going to go up 1 over 4. And down 1, left 4. To get a general sketch. And now we're going to connect these. And this is f inverse of x. So if we're looking at domain and range, the domain of f of x is negative infinity to positive infinity, along with the range. And if we look at domain and range of our inverse function, it is the same. So the last step is to verify that these functions are inverses of each other. So to verify that, we want to show that f of f inverse of x is equal to x, and that f inverse of f of x is equal to x. So what we can do is, I'm just going to put this in another spot so I have a little bit more room. So starting with f of f inverse of x, we have this is equal to 4 times the quantity x plus 5 over 4 minus 5. And by using distribution, we see that this does simplify to just x. And then we also want to show that f inverse of f of x also equals x. So by substituting f of x into the inverse of f of x, we have 4x minus 5 plus 5 all over 4. And using order of operations combining, we do see that this simplifies to just x. So therefore, this shows us that f of x and f of inverse of x are inverses of each other. Nice work!